Good day everyone. We are now in chapter 3 on the processes of operating systems. Just a few recall po dun sa pinag-usapan natin for chapter 2, say that the system consists of a collection of processes such as the operating system's processes to execute the system code and user processes to execute the user code. So potentially all these processes can execute sabay-sabay concurrently with CPU or maaring maraming CPU. By switching the CPU between processes, the operating system can make the computer more productive. So in this chapter, you will learn about what processes are and how they work. Ito po yung contents ng ating chapter 3. Our goals in this chapter are listed here. The definition and context of processes related to operating systems will be emphasized. We have to deal with the features and states of process and explore the internalities. This chapter discussion will be concluded with the client-server communication systems. Pag-usapan po natin si process. So, sa subject na to, pag sinabi nating process, we refer to job. Pareho lang po sila. A process is a program in execution. Program in execution. Ay, wala po tayong ink. Tingin. Okay. So, to emphasize, a process is a program in execution and that the execution must progress in a sequential fashion. Pagkasunod-sunod. A process is defined as an entity which represents the basic unit of work to be implemented in a system. So we write our computer programs in a text file and then we execute the program and that it becomes a process. A process is more than a program code na nilalagay po natin sa text section. Diyan po tayo nagko-code. The operating system makes use of the text section so that it can recite the program code. It also includes the current activity as represented by the value of the program. So may counter po siya like incrementation and it contains the processor's registers as well. So a process generally includes the stack, yung principle ng last in first out, which contains temporary data such as function parameters, returns address, and local variables. The data section, which contains the global variables as processes may be associated to other processes. A process includes the heap containing the memory that is allocated during the process. Okay, so if the process is an active entity, meron din po tayong passive entity. So we relate and contrast this to a program. If say we have a program like .xls, .ppt, yun po yung mga static file natin. It is a passive entity if you put it on a storage device like your hard disk. So kailangan magalaw po si passive entity, like you wanted to play the video, load nyo, i-open, isi-save po ninyo, that will be that passive entity will be converted into an active entity kasi ilo-load na po siya at meron na pong activity. In contrast, so a process is an active entity within a program counter specifying the next instruction to execute and the set of associated register. A program becomes a process when an executable file is loaded into the memory. So, pag gagalawin mo siya, si program, magkakaroon po siya ng action that becomes now the process. Okay? So, please bear that in mind. Next, meron po tayong multiple parts. Ito po yung organization ng ating process in memory and that there are parts associated to the process. It contains your text, your data section. We have the heap and the stack. These are all embedded in a process. Okay. So, we have the we have the process state. So, si process state, meron siyang 5 major transitions. So, what are these 5 major transitions? So it is progress from the new, then you have the running, waiting, ready, and terminated. Now, eto mga term na to, maaaring magkaiba po yung tawag ng iba't ibang operating systems. New, like create, pareho lang yun. Terminated, quit, exit, pareho lang yun. So, yung connotation ng meaning pareho, pero the operating systems might use it differently. So, that states that they represent that the states that is represented are found on all systems. Certain operating systems also have the alienated processes. Maaring yung mga processes na to might cascade to other sub-processes, but these are the major states. It is important to realize that only one process can be running on any processor at any instant. Kahit marami pa yan, mabilis lang po talaga mag-process si computer, of course, with the techniques and algorithms of the operating systems, maximizing the CPU at all times. Kaya kahit anong dami ng processes na makikita natin on progress internally, there's only one process that can be running at the processor at an instance. So, ito po yung ating progress of the process state. We have the new on the first state, then it will progress as it is admitted. That will be on the ready state. Then you have the running state. So under the running state, we have three conditions. Either there is an interrupt from the operating systems. After running state, mag-wait pa po siya on an event. Until then, after all these iterations on the running state, it will exit the queue. Okay, kasi nakapila po yung lahat ng processes natin. We have the process control block. The process control block contains pieces of information associated with a specific process. So, there is that process state. Okay, yun yung kanina. We have the new, ready, running, waiting, and terminated. We have the program counter that indicates the address of the next execution. We have the CPU registers that may vary in number and type depending on the computer architecture. So, the CPU registers include accumulators, index registers, the stack pointers, and general purpose registers plus the condition code information. Yun po yung inaral ninyo sa computer architecture. Along with the program counter, the state information must be saved when an interrupt occurs to allow process to be continued correctly afterwards. There is the CPU scheduling information, and it includes a process priority. Yan naman po yung ating chapter 4. There is memory management information system. These include items as the value of the base and limit registers and the page tables. Kasama din po si segment table depending on the memory system used by the operating system. There is the accounting information, which includes the amount of CPU, the real-time use, the time limits, yung mga account numbers, job or processes numbers. The input-output status information contains the list of input-output device allocated to the process. The list of open files are also given. Okay, so CPU switch. The CPU switch, meron po siyang kakambal na pangalan, si context switch. So, pag sinabi naman natin CPU switch at context switch, dito sa subject natin, pareho lang po siya ha. A context switch is the mechanism to store and restore the state of the context of a CPU in process control block so that the process in execution can be resumed from the same point at a later time. Using the technique, a context switcher enables multiple processes to share a single CPU. Context switching is an essential part of a multitasking process. In this example, we have two processes. We have process PO and process P0. The goal of the operating system is to maximize the CPU utilization at all times. Kaya pag nakita halimbawa ni operating system na si PO ay idle, si operating system will issue an interrupt o di kaya system all. O since idle ka, trabahuin mo muna si process P1. So if there are executions on process P1 at natapos po niya ito, tsaka lang po siya babalik sa ibang processes. Though the CPU is switching from different processes, there is that memory kasama po doon sa attribute ni process control block. Alam niya kung saan siya huminto dito sa process P0 at saan po yung ginawa niya sa process P1. And the moment that the job is done, it will just go back to the previous processes. So, ito, kung bakit niya naalala, bakit siya nagsiswitch, yung program counter, yung progress, ay nababalikan niya. It's because there is that functionality of the process control block. Yun yung kanina pinag-usapan natin. At meron po kasi mga attributes si process control block so that it can switch from one process to another. Okay? Okay, from the idea of the context switch, and that processes could just be shifted from one process to another, and there are subroutines of the processes, and these subroutines are associated with the process, and simultaneously mayroon pong context switch. So dito po nanggagaling si concept ng thread. A thread is a path in execution within a process. So kung walang process, ibig sabihin walang thread, kasi sa loob po ni process ay nandoon si thread. A thread is a path of execution within a process. So, ang process na yan can contain multiple tasks. Bakit nagre-requires po si OS sa multi-threading? Because a thread is to achieve parallelism by dividing a process into multiple threads. Halimbawa, nagbubukas ka ng browser. So, when you are opening the browser, maaari you are working simultaneously with sub-processes. Along with this browser, may binubuksan ka, halimbawa na nag-email ka, nagbubukas ka rin dito ng YouTube, o may meron ka pa rin pa-FB. So, itong maliliit na processes dito sa browser natin are considered as the lightweight process, and these are your thread. Okay, so parallelism, it means to say that we can manage to work simultaneously with these different tabs. Okay, now we have here the representation of the process in the implementation of Linux operating system. A process control block in the Linux operating system is represented in the C structure. So, meron tayong C structure task. So, this is included in the header, and this structure contains all the necessary information for representing a process, including the state of the process. The scheduling and memory management information is in charge. There are a list of open files and pointers to the process parent, and a list of its children and probably siblings. So a parent process is the process that created. Its children are any processes that it creates. So, an example of the state process is represented in this structure. Within the Linux kernel, all active processes are represented through the link. Okay? So, tingnan niyo po mabuti yung ating structure. So, we have the initialization of the parent process. Sa parent process ay mag-create po ng child processes. Now, there are links to these processes. Maaring ito ay associated with the linked list. Okay, so in this example, meron tayong thread that is being maintained from the parent processes. The kernel maintains a pointer. So the process currently executing on the system can be specified in this process. So, this structure contains all the necessary information in a process, including the embedded states. Okay, so it can work simultaneously with other modules. So, the parent is the process. The parent is initiated, and once the parent is initiated, there are simultaneous execution on its children. The process scheduling. So, the objective of multi-programming is to have some process running at all times and that is to maximize CPU utilization. The objective of time sharing is to switch the CPU among processes so frequently that users can interact with each program while it is running. A process enter the system. So, pag process pumasok na sa system, pipila po yan sa job queue. Okay? Muna siya sa job queue, which consists of all the processes in the system. The processes that are residing in the main memory and are ready and waiting to execute are kept in the ready queue. So, progress po from job queue to ready queue. The queue is generally stored as a linked list. Kaya nga yung queue, yung pagkasunod-sunod. Ready queue header contains pointers to the first and final process control block in the list. So each process control block includes a pointer field that points to the next process control block in the ready queue. When a process is allocated, the CPU then assigned the sequence. So ang kanyang i-queue now are yung pagkasunod-sunod. So, from the ready queue, and then what will happen after the ready queue, there are consideration of the device queue. So, ano naman po yung gagawin ngayon ni device queue? It set processes waiting for an input-output device. So, maaring magtitrigger po doon si mouse, magtitrigger po si keyboard from the input-output device. The process that makes an input-output request also make use of shared devices such as a disk. So, since there are many processes in the system, that disk may be busy with the input-output request of some other processes. So, nakakasama si device queue on the process scheduling. So, it will progress from job queue to ready queue and even extend to the device queue. Well, we ended up to this diagram kanina, so we'll have the illustration. All processes are stored in the job queue, and the processes in the ready state are placed in the ready queue. Processes waiting for a device to become available are placed in the device queue. There are separate device queue for each devices. Like in this case, we have the magnetic tape. We have magnetic tape on unit 1. We have disk 0. So there is a separate device queue for each queues, and the other requests may also be created as used as needed. So lahat ng mga processes which is stored on the different queue are associated to the process control block. So the moment that there is the supervision of the process control block, it can manage to work with the sequence, with the counters, with the attributes of the processes. We have the representation of process scheduling. Saan nga ba napupunta si queue, ano po yung kanyang progress. So in relevance to the representation of a queue, we have here the representation, and on the figure you are seeing rectangular box. So pag naka-rectangle, sabihin nakapila po siya, that is on the representation of the queuing diagram. Pag may nakita naman po tayong mga circles, okay, the circles represent the resources that are served in the queue, and the arrows indicate the flow of process in the system. So let's try to observe what is in this sequence of in the diagram. A new process is initially put in the ready queue. So pag create ng process, pipila po siya sa ready queue. It awaits there until it's selected for execution. On the process, okay, dito. So, pag progress po ng process from a ready queue, pupunta po siya sa CPU and is waiting for the following conditions. Ito. So, si process ay nandito na po sa CPU, and there would be 3 or 4 possible conditions. So with these conditions, the process could issue an input-output request and then be placed in an input-output queue. The process could create also a new child process and wait for the termination. The process could be removed forcibly from the CPU as a result of an interrupt and be put back in the ready queue. So the process eventually switches from the waiting state to the ready state, and then it put back to the ready state again. So there is the migration of a process. The process eventually will exit pagkatapos po niyang ma-execute. Agad-agad napupunta po siya sa exit. Minsan sa pag-exit po ng process, it is terminated normally, and sometimes it is terminated abnormally. But the thing is, the moment that it exits on the PCB, it is deallocated. The schedulers. So, a process migrates among various scheduling queue. Yung kanina pinag-usapan natin na we have job queue, we have the ready queue, at we have the device queue. All through its lifetime, andun po siya nakapila until mag-exit po siya sa ating CPU. The operating system must select for scheduling purposes the processes from these queues on different criterion. So the selection process is carried out by the appropriate scheduler. So often, meron tayong tinatawag na batch scheduler where the processes are preconditioned and that can be submitted for execution. The processes are spooled to mass storage device, like you have the secondary storage device, a disk, where they are kept for later execution. The long-term scheduler or job scheduler select processes from the pool and loads them into the memory. So, doon gumagana si long-term scheduler. Kailangan ma-load po siya sa memory. It has to be loaded in memory because it has to stay for a while. Si short-term scheduler naman, or the CPU scheduler, selects from among the processes that are ready to execute and allocates the CPU to one of them. So, diretso siyang ipaprocess sa CPU, kaya short-term scheduler. The primary distinction between these two schedules or schedulers lies in the frequency of the execution. So the short-term scheduler must select a new process for the CPU frequently. Si long-term scheduler naman, it is in charge of the multi-programming, the number of processes in the memory. So if the degree of multi-programming is stable, then the average rate of process creation must be equal to the average departure rate of processes leaving the system, making it available for new set of processes. And the cycle kanina will continue. Okay? So, we made mention about the long-term scheduler. We have the short-term scheduler. This time, we have the medium-term scheduler. The idea behind a medium-term scheduler is that sometimes it can be advantageous to remove a process from the memory and from active contention for the CPU. And thus, it reduces the degree of multi-programming. So later, the process can be reintroduced into memory and its execution can be continued where it left off. This scheme is called swapping. So, ang nangyayari po sa medium-term scheduling is the swap in and swap out. And the queue happens on the execution of the processes. The process is swapped out and is later swapped in by the medium-term scheduler. Swapping may be necessary to improve the processes or the mix of processes because a change of memory requirements has overcommitted the available memory. So, requiring the memory to be free. Okay. We have the application of multitasking in mobile systems. So, sa mobile systems, so we'll have it considered on the iOS device and the Android application. Yung unang version ng iOS, the iOS did not provide user application multitasking. Only one application runs in the foreground and all other applications are suspended. So we have the consideration here of the foreground and the background as applied to the iOS mobile devices. The foreground application is the application currently open and appearing on the display. The background application remains in the memory but does not occupy the display screen. So the iOS 4 programming API provides support for multitasking, and that it allows a process to run in the background without being suspended. So Apple probably limits multitasking due to the battery life and memory use. So they choose not to take advantage in order to better the resource use. Now, if we will compare this with the Android system, Android does not place constraints on the types of applications that can run in the background. So if an application requires processing while in the background, the application for Android must use a service, a separate application component that runs on behalf of the background process. So pag nagsistream halimbawa ng audio application and the applications moves to the background, the service continues to send audio files to the audio device running on behalf of the background. So the service will continue to run even if the background application is suspended. The services do not have a user interface on the audio and have a small memory footprint. It provides an efficient technique for multitasking in a mobile environment. Next, we have the idea of a context switch. We mentioned a while ago that the context switch is also referred to the CPU switch. Interrupts cause the operating systems to change. So a CPU from its current task and run on a kernel routine. Such operation happen frequently on general purpose system. When an interrupt occurs, the system needs to save the current context of process running on the CPU so that it can restore that context when its processing is done, essentially suspending the process and then resuming it. The context is represented by the process control block. So, yung pinaka-functionality ni process control block is manifested every time there is that context switch. So, in between the processes, the switching of processes, lies the process control block. Okay. So, we have the operations of processes. The processes in operating systems can execute concurrently and they may be created and deleted from time to time. So systems must provide a mechanism for process creation and termination. Unahin po natin si process creation because we wanted to relate and contrast this to process termination. Si process creation considered here on a parent and child processes. So, pag nagbukas ka ng isang program, maaaring with the execution, meron siya mga sub-processes. A process may create several new processes, and that creating a process is called a parent process. Si parent process can create a new process that are called children of that processes. So, there is the process identifier that is being managed every time there's the creation of the children. We have the resource sharing options. The parent and children share all the resources. So, minamana ni children yung resources ni parent. Children share subset of parents' resources. Take note that it is only a child is only a subset of the parent's resource. Parent and child share no resources. This could be a resource sharing options. Maaaring magiging independent po si parent and child when it comes to resources. So, in the execution options, we say that the parent and children are working concurrently and then parent awaits until the children terminate. Okay, so please take note of these conditions. It might be confusing, but let's try to implement this on the concepts para mas naiintindihan po lalo. So, a tree of process in Linux. So, this is applied to an operating system named Linux. Now, with the structure of a tree, we say that the tree contains the roots. The roots have subroots, the left and the right wing. Anything that is associated to the roots, it is rooted from its parent. The figure illustrates a typical process tree for Linux operating systems. Like we have the init process, and that it serves as the root parent for all the processes. Ito. So, nanganak si init with the login, with the kthread, and SSHID. So, itong capability ni child processes was rooted from the parent. Once the system has booted, the init process can also create various user processes such as the print server, webman po yun. So, an SSH, okay, and kthread originated from init as well. So, the kthread process is responsible for creating additional processes that perform tasks in behalf of the kernel. So, in this case, we have the khelper and PD flash. So, the login process is responsible for managing clients that directly log into the system. And in this client example, if say the system has logged using the bash shell, log siya gamit po yung command line interpreter ni Unix, then the bash shell command interface would be available for the user. So, pwede niya nang gamitin po yung lahat ng functionalities associated sa bash shell. Say, meron po mga attributes si bash shell. Bash shell is capable of PS command, like you wanted to know the functionalities and the attributes, it will list all the information. So, the moment na ginamit mo po si bash shell and all its attributes, ibig sabihin, you have to first open the root. Kailangan muna nandun ka sa program. Well, it is easy to construct a process tree similar to the figure, kasi from time to time, a tree organizes the entirety of the process and all other sub-processes are rooted from the root. Like when you open Microsoft Word, pag open mo ng Microsoft Word, nakakapag-print ka, nakakapag-type ka, lahat ng functionalities. Pero kung hindi mo bubuksan si Word, all other functionalities para gumawa ng documents, it will not be available for you. Now, on the sub-menus like file, so pag-click mo si file, yung mga sub-roots niya, like you have the open, you have the save, you have the print, will be available for you. So, that is the sub-root for the file. Now, sa Microsoft Word, there are menus, and those menus, it represents the sub-menus. So, sa bawat pull down, like file, like view, meron po siya mga sub-processes that is available. Okay? We have the process creation. When a process is created, there is the inclination that there is also a child process. If it's a bigger program, the child process will need certain resources like the CPU time, you have the memory files, input-output devices to accomplish a task. A child process may be able to obtain its resources directly from the operating system, or it may be constrained to a subset of the resources of the parent process. Yung condition kanina na kunento natin. Now, the parent may have to partition its resources among its children, or it may be able to share some resources such as the memory or the files. So, among several children, ito po yung kanyang mga attributes na nakukuha sa parent. Restricting a child process to a subset of the parent's resources prevents any processes from overloading the system from a parent, and that it would be an instance to a child process. So, pwede siyang mag-restrict. Pwede din po siya sa parent mag-extend. So, a fork system creates new processes. Pag may parent process, if you fork a process, then there is an instance for the child process. We have here the program. Okay? So, fork system call is used to create a new process, which is a child process, which runs concurrently with the process that makes the fork function call. So, after a new child process is created, both processes will execute. So, the next instruction following the fork system call is continued. So, along with this functionalities, there are parameters, and there are value associated. So, dito sa example natin in return process, we have the associated child processes that it can return a negative value less than 1. Creation of a process was unsuccessful in this condition if this is a subroutine. We have the 0 and return the newly created child processes. Maaring there is also another condition, and this time if it's not 0, it's not negative, then it's positive, and it returned to a parent or a caller. So the value contains the process ID of the newly created process. Okay, so next we have the illustration of the create process function, which creates a child that loads the application in MS Paint. Okay, so ano po, pag inopen natin halimbawa, we have the conditions stored on MS Paint. Okay, so in this example, we have two parameter process through the system call. There is a system call that can be invoked by the parent process, and that is to be terminated. Otherwise, kung hindi niya ita-terminate yun, the process can still be working on a zombie or orphan process. Remember the concept. So, a parent may terminate the execution of one of its children for a variety of reasons, like the child has exceeded its usage of some resources that it has been allocated, so ito terminate the parent. The task assigned to child is no longer required. Natapos niya na yung trabaho, so it's no longer required. The parent is already closing, and the operating system does not allow a child to continue if its parent terminates. So the process termination is associated to a process, and it is also extended to its child processes. We have the multi-process architecture in Chrome. So in this case, we have the so in this figure, it implies that there are websites that may contain active content. So if it's active content, maaaring there are simultaneous workings of the programs. It's associated files, like meron siyang binubuksan na HTML, there is JavaScript, and thus it provide a rich and dynamic web browsing experience. Well, unfortunately, these web applications may also contain software bugs, which can result in sluggish response time and can even cause the web browser to crash. Experience po natin, lagi na tinatanong tayo if we will continue or exit, o di kaya kill the operation. This isn't a big problem in a web browser that displays content from only one website, but most contemporary web browsers provide tab browsing. Nagbubukas na ngayon ng maraming program, maraming additional tabs doon sa browser, which allows us on a single instance of a browser application to open several websites on the same time. Ito yung lagi natin ginagawa because we wanted to maximize our time, and there's a switch between the different sites, so a user need only to click on the appropriate tab. This arrangement is illustrated dito po sa figure. Okay, so we have here the browser with the different tabs. The implication is that there could be a problem with this approach, that if a web application in any tab crashes, the entire processes, including all the tabs displaying additional websites, may crash as well. Kasi yung pinaka-parent process ni browser yung mag-override. The Google Chrome web browser was designed to address this issue by using a multi-process architecture. So the Chrome identifies 3 different tasks of browser. So, mayroon siyang processes like we have the renderers, we have the plugins, and the browser itself. So, first, we talk about the capabilities of the Google Chrome browser. So it is responsible for managing the user interface as well as the disk and network, the input-output operations. So a new browser process is created when Chrome is started. Isa lang yung kanyang default. Only one browser is created. Then we have the concept of the renderer. It contains the logic for rendering the web pages. They contain the logic for handling the HTML, yung JavaScript code, the images, and many other resources. So as a general rule, a new renderer process is created for each website that is open on the new tab. Several renderer processes may be active at the same time. Merong plugin. A plugin process is created for each process, such as Flash, may QuickTime. In the use of plugin processes, it contains the code for the plugin as well as the additional code that enables the plugin to communicate with the associated renderer process and the browser processes. Well, in this case, the advantage of the multi-process approach is that websites run in isolation from one another. If one website crashes, only its renderer process is affected. All the other processes remain unharmed. Okay, so they are still, though these processes are interrelated, we still have the consideration of the dependencies of its past. Okay, so merong concept na sandbox. So the renderer processes and run in a sandbox, which means that the access to disk and the network input-output is restricted, and thus it minimizes the effects of security problems. We have here the communication models. This only applies to cooperating process. Pag meron po tayong several processes, meron tayong communication models. So, kung isa lang yung process, wala po tayong sender and recipient. The cooperating processes requires an inter-process communication or the IPC mechanism that will allow the communication to exchange data in the information. There are two fundamental models of inter-process communication. We have the shared memory passing. Ito po. Sa A, we have the shared memory passing, where there is that region of memory that is being shared by the cooperating process. There is that region in the memory that is being shared by the cooperating process. The processes can then exchange information by reading and writing data to the shared region. So in the message passing model, we have the communication that takes place by means of messages. M0, M1, M2, these are for the messages. In further, dito po sa message passing, merong tayong communication links that is being exchanged by the different processes. Okay? So, dito naman sa process A and process B, we have another model which we call this as shared memory model. Ang sinishare po nila is the resources of the memory. Going back, kasi the very foundation of our communicating models is our cooperating process. So process executing concurrently in the operating system may be either independent process or cooperating process. Ang pumapasok po sa communication models is the cooperating process. So a process is however independent if it cannot affect or be affected by the other processes executing in the system, kasi dedicated po yung OS sa isang process lang. However, there are processes that does not share with any other processes. Pero most of the time, the operating system maximize its utilization. Kaya marami po siyang ina-accommodate na mga processes. So, cooperating processes can affect or be affected by other processes. That's why we have communication models, sharing a memory or sharing a message. In any process that shares data with other processes is considered to be a cooperating process. Sa cooperating process, there are features. Okay, ano po yung mga features na to? We have information sharing, computation speed up, modularity, and convenience. So, these are good things about the cooperating process. Let's talk about the information sharing. Since several users may be interested in the same piece of information, like a shared file, the operating system must provide an environment to allow the concurrent access to such an information. Yun po yung contention ni information sharing. If we want a particular process to run faster, we must break this into subcomponents. So each of which will be executing in parallel with the others. So there is that speed up. The feature is more on speed and can be achieved only if the computer has multiple processing cores. That's for the goal of the computation speed up. Sa modularity naman, maaring we want to construct the system in a modular fashion, dividing the system functions into separate processes or threads. So that is the goal of working simultaneously through the threads, and we make use of the PCB and the CPU switch. Sa convenience naman, we consider to work in many tasks. Tayo gusto natin lagi mabilis yung system, lagi po siyang nagre-respond. So the user may be wanted to open several files, like gagawa po siya ng documentation sa Microsoft Word, nakikinig po siya ng music, nagda-download po siya sa kabila, and these features is for convenience. Let's have the producer-consumer problem. Ito, ang producer-consumer problem is for the bounded buffer. Pag may limitation lang po si bounded buffer. Pero wag po natin kalimutan na meron po tayong dalawang klase ng buffer. The unbounded buffer and the bounded buffer. Si unbounded buffer places no limitations, no practical limitations on the size of the buffer. So, since unli po siya, wala po tayong problema dyan. Okay, marami siyang resources. Si bounded buffers assumes that there is a fixed memory size. So, limited lang. Minsan, bibigyan kayo niya ng resources like the buffer is equal to 4. So, then, you have to make use of these resources. Because of this limited resource, nagkakaroon po tayo ng problem sa producer-consumer problem. Now, ito ay nangyayari sa cooperating process. In a producer-consumer problem, which is a common paradigm for cooperating process, we have the metaphor for a client-server paradigm. We think of a server as a producer. So we think of a server as a producer and a client as a consumer. Example, si web server produces HTML files, the image, which are consumed and ready, binabasa, binamanipulate ng client on a web browser. So, si consumer requests for this resource of the producer. Ngayon, one solution to the producer-consumer problem is through the shared memory to allow the producer and consumer process to run concurrently. We must have available buffer of items that can be filled by the producer and emptied by the consumer. So this buffer will reside in a region of memory that is shared by the producer and the consumer processes. A producer can produce one item while the consumer is consuming another item. So the producer and the consumer must be synchronized so that the consumer does not try to consume an item that has been or not yet been produced. So, in this example, if we are to consider the producer here, so si producer, magpo-produce lang po siya if there are available memory sa buffer. Okay? So, wala pong problema doon. Pero kung si producer will produce at hindi naman itong si consumer, halimbawa, nagtitake ng kanyang na-produce, mapupuno po itong buffer. So, problema ni producer kung paano siya pagpuproduce pa dahil wala na po siyang available memory. Si consumer naman, halimbawa, hindi po siya nag-consume. Hindi siya nag-consume. Kung hindi siya nag-consume, mangyayari, mapupuno po ito. So, in effect, ang pinaka-idea po dyan is, as the producer is giving all these resources, dapat nakukonsume ni consumer. Kung wala naman pong naiproduce itong si consumer, empty to, wala din pong resources na magagamit o mai-enjoy ito si consumer. So, the problem for producer-consumer problem is solved using synchronization or semaphores. So, pag-uusapan po natin yan sa next chapter. So, for now, let it be na we have to manage the resources on the client, the server, the processes side. So, if these are managed accordingly, then everything will work well and there will be no problem for the operations. Okay. We have the illustration of a bounded buffer. So, tingnan po natin yung bounded buffer algorithm. This illustration illustrates communication using a shared memory. So, we have here buffer size. Okay, the initialization, we have in 0, we have in out. The variables reside in a region of memory shared by the producer and consumer processes. The shared buffer is implemented as a circular array with two logical pointers. Because it will be accommodating the set of resources as this example illustrates it on a buffer. Okay. We have the producer. So, the producer process has a local variable next produce in which the item is to produce and stored. So, ito yung pinaka-functionality ni producer. We have the consumer. See, the consumer processes has a local variable also. Meron siyang local variable and then the next is consume in which the item is stored. So, consume the item in next consume. So, this is synchronization between the previous example of the producer and consumer. We are now on the implementation of message passing in inter-process communication. Message passing provides a mechanism to allow processes to communicate and to synchronize actions without sharing the same address. It is particularly useful in a distributed environment where the communicating processes may reside on different computers connected by a network. So, for example, in the internet chat program, there is the designed implementation so that chat participants can communicate with one another by exchanging messages. A message passing facility provides at least two operations, that is send and receive. So, if process P, so we associate send to P, receive for Q. So, if process P and Q wants to communicate, they must send messages to and receive messages from each other. A communication link must exist between them. So, the link could be implemented in a variety of ways. And the link could be in the physical implementation, which uses resources like shared memory, the hardware bus, or the network. The logical communication link could be direct or indirect, synchronous or asynchronous, or it could be automatic or through an explicit buffer. The implementation questions on communication link. A link po kasi has some capacity that determines the number of messages that can reside in the temporary link. So these questions are given every time we have to consider the links from send and receive communication. First, we have to consider direct communication. In direct communication, each process wants to communicate must explicitly name the recipient. So, kailangan pangalanan. Processes must name the recipient, either the sender or the receiver. So, in this scheme, the send and receive primitives are defined. So, we have P for send a message to process P. We have receive Q message, and that is a message from process Q. So we have here the properties of communication link. Indirect communication. The messages are sent to and received from mailboxes or ports. A mailbox can be viewed as an object into which messages can be placed by process and from which messages can be reviewed. So each mailbox has a unique identification. Like in POSIX message queues, an integer value is used to identify the mailbox. A process can communicate with another process through different mailboxes. Two processes can communicate, can be communicated if they have a shared box. So, kung meron silang halimbawa communications through a shared mailbox, this send and receive can establish communication. On the concept of synchronization, there would be communication between process that takes through the functions send and receive. The different design options for implementation are through message passing and maybe either block or non-blocking. So, pag nag-synchronize, either the implementation or is on blocking or synchronous, non-blocking, or asynchronous. So, by blocking send under blocking or synchronous messages, the sending process is blocked until the message is received by the receiving process through a mailbox. Si blocking is received once the receiver block and until the message is now available. Sa non-blocking, or we consider this as asynchronous communication. Non-blocking send is that the sending process sends the message and resumes the operation. Si non-blocking naman in asynchronous communication receive the message, and that we say that the receiver retrieves either a valid message or a null. So, itong consideration natin for synchronization. Now, let's establish this in a program. So, different combinations of send function, and receive functions are possible. When both send and receive are blocking, we have communication between the sender and the receiver. The solution on the producer-consumer problem becomes trivial when we use blocking send and receive statements for synchronization. The producer invokes the blocking send and waits until the message is delivered to either the receiver or the mailbox. Likewise, when the consumer invokes receive, it blocks until the message is available. Okay, so we have the concept of buffering. So that we have the implementations. The queue of messages attached to the link is implemented in three ways. We have the zero capacity, and the queue has maximum length of 0, thus the link cannot be doing any messages. The link cannot have any messages waiting. So in this case, the sender must block until the recipient receives messages. So bounded capacity naman, ang queue has a finite length. Ito yung naging problem sa producer-consumer problem. Thus, at most, n messages can reside in it. So if the queue is not full, when a new message is sent, the message is placed in the ready queue. Either the message is copied or it is stored on a pointer. Okay, nalilink siya through a pointer, and the sender can continue execution without waiting. The link's capacity is finite, So if the link is full, the sender must block until the space is available in the queue. See unbounded capacity. The queue's length is potentially infinite, thus any number of messages can wait in it and the sender is never blocked. Now, on some implementations, we have examples of the IPC systems on POSIX systems. So, the mechanisms are available for POSIX systems, including the shared memory and message passing. So, we explore the POSIX API for shared memory. Shared memory in POSIX is organized using memory mapped files, which is associated to the region of shared memory within a file. Yung kaninang consideration natin sa shared file, yung message passing and shared file. This time, we have the implementation on shared file lang. So, a process must first create a shared memory. So, a process must first create a shared memory object using the open function call. Okay, ito. The first parameter specifies the name of the shared memory object. Processes that wish to access this shared memory and refer to the object by this name. So, the object parameter specify that the shared memory object is to be created. Ito. And that the object is open for reading and writing. It's open for reading and writing. The last parameter establishes the directory permissions of the shared memory object. A successful call, like open, returns to an integer in the file descriptor shared memory object. So once the object is established, there is the ftruncate, okay, the size of the object function that is used to configure the size of the object in bytes. So the ftruncate, to SHFD variable sets the size of the object to 4096 bytes. So finally, there is that memory object. Okay, the memory object, to, it also returns the pointer to the memory map file that is used for accessing the shared memory object. On the synchronization, we have the consideration of producer at saka consumer. So the producer shown in this code, to, shared memory object name OS, shared an object named OS, ito, and writes the string hello world to the shared memory. The program memory maps a shared memory object of the specified size and allows writing to the object. So there is that map shared specifies that changes to the shared memory object will be visible to all the processes sharing the object. We write the shared memory object by calling the sprintf function and writing the formatted string to a pointer. After each write, we must increment the pointer by the number of bytes written. So, yun yung pag-synchronization niya na we have to consider the number of the counter, the producer shown in this code. Consumer na pala tayo. So, if we have now the consumer, okay, the consumer processes reads and outputs the contents of the shared memory. The consumer also invokes the unlink function, which removes the shared memory segment after the consumer has access. So there is a communication between the bounded buffer, which is being set by the operating system. So the synchronization happens from the producer side and the consumer side. So this is a function where the two objects are synchronized and that buffers are fully utilized. The example on IPC systems as regard to the Mac communication. Mac operating system kernel supports the creation and destruction of multiple tasks which are similar to process but have multiple threads of control and fewer associated resources. Most communication in Mac, including the intertask, is carried out by messages. Messages that are sent to and received from mailboxes. The mailboxes needed for communication are created through port allocate. So the kernel uses the kernel mailbox to communicate with the task and sends notification of event occurrences to the notify port. Only 3 calls are needed for the message transfer. So we have the message send, the message receive, and the message RPC, remote procedure call. A message is on a send function if it sends a message to a mailbox. A message is received through message box through the receive function. The remote procedure control are executed through the message RPC, which sends a message and waits for exactly one return message from the sender. So in this way, the RPC models subroutine procedure call is initiated. The port allocate, system call creates a new mailbox and allocates space for its queue of messages. The send and receive operations themselves are flexible. So when a message is sent to a mailbox, the mailbox may be full. So if the mailbox is not full, the message is copied to the mailbox and the sending thread continues. If the mailbox is full, the sending thread has 4 options. Wait ng matagal. Wait at most in milliseconds. Ibig sabihin, may specific na oras. There is the overhead. And return immediately or di kaya temporarily cache a message. The implementation of IPC and Windows system. The Windows operating system is an example of modern design that employs modularity to increase functionality and decrease the time needed to implement new features. So Windows provides support for multiple operating environments or subsystems. Application programs communicate with subsystems through a message passing mechanism. The application programs can be considered as clients of a subsystem server. Now, this figure, Windows uses a port object to establish and maintain a connection between two processes. So, Windows uses 2 types of ports, the connection ports. So, we have the connection ports and the communication port. Server processes publish connection port objects that are visible to all processes. When a client wants services from a subsystems, it opens a handle to the server's connection port and sends a connection request to that port. The server then creates channel and returns a handle to the client. The channel consists of a pair of private communication ports, one for the client server messages, the other for server client messages. So communication channels support callback mechanisms that allow the client and server to accept requests when they would normally be expecting a reply. So one of the 3 message passing techniques is chosen. Like in this case, you have the section object. For small messages, it is up to 256 bytes. The port's message queue is used as an intermediate storage and message are copied from one process to another. So, dito ang implementation niya is less than, or shall I say, up to 256 bytes. The larger messages must be passed also through a section object, which is a region of shared memory associated with the channel. When the amount of data is too large to fit into a section object, there is that API that makes it available for the server processes to read and write directly into the address space of a client. The communications in a client-server systems. It is associated through sockets, remote procedure controls, or remote procedure calls. We have the pipes, remote method through Java implementation. So let's talk about the socket. A socket is defined as an endpoint for communication process. A pair of processes communicating over a network employs a pair of sockets. So one for each process. A socket is defined by an IP address concatenated with port number. So in general, the sockets use a client-server architecture. The server waits for incoming client requests by listening to a specified port. Once a request is received, the server accepts a connection from the client socket to complete this connection. Servers implementing specific services like merong FTP o di kaya Telnet, HTTP, listen to well-known ports. So when a client process initiates a request for a connection, it is assigned by a port through its host computer. The port has consideration on the port number. So titingnan po natin yung communication between the host and the web server. Now, in this illustration, the client on host X with IP address 146.86.5.20, ito si host X, wishes to establish connection with a web server which is on port 161.25.19.8. Okay. So the host X may be assigned a port, like in this case you have 1625. The connection will consist of a pair of sockets on host X, and this is on web server. This situation is illustrated on socket communication, and the packets traveling between the hosts are delivered to the appropriate process based on the destination port number. All connections must be unique. So, yung connections with the port and the IP addresses must be unique. If another process on host X wish to establish another connection with the same web browser, it would be assigned a port number greater than 1024 and not equal to 1625 anymore. So this ensures that all connections consist of a unique pair of sockets is possible. So the Java provides three types of sockets. That is connection-oriented, TCP, connectionless, UDP sockets, using the datagram socket, and we have the multicast socket, which is a subclass of the datagram socket class. So our example here describes a date server that uses connection-oriented sockets. So the operation allows clients to request the current date and time from the server. The server listens to port 6013 on the server socket, although the port could have many arbitrary number greater than 1024 as discussed previously. So when a connection is received, the server returns the date and time to the client. The server creates a serve socket that specifies that it will listen to port 6013. The server then begins listening to the port in the accept method. So we have here the set of codes associated to the processes. The server blocks on the accept method is waiting for a client request connection. When a connection request is received, then there is that function on accept that returns a socket and that the server can use to communicate with the client. The details of how the server communicates with the socket are through the server. So, ang unang ginagawa ni server is that it first establishes the communication. The server creates serve socket, which has on 61.3, and the details here are as follows, like print writer object. So we have here the object that will use to communicate within a client. A print writer object allows the server to write to the socket. The client communicates with the server by creating a socket and connecting to the port which the server is listening. So this implementation, a client in the Java program is designed, okay, where the client creates a socket and requests connection with the server. So once the connection is made, the client can read from the socket using a normal stream input-output statements. After it has received the date from the server, the client closes the socket. Okay, it closes the socket. Otherwise, there is the trap statement to be released. Let's proceed to remote procedure call. The remote procedure call was designed as a way to abstract the procedure call mechanism for the use between systems with network. So it is similar in many respects to the inter-process communication mechanism, and it's usually built on top of such a system. However, we are dealing with an environment in which the processes are executing on separate systems. So we must use a message-based communication scheme to provide remote services. Now, if we compare this to inter-process communication messages, the messages exchanged in RPC communication are well structured and they are no longer just packets of data. Each message is addressed to RPC daemon listening to a port on the remote system, and each contains the identifier specified on the function. The function is then executed as a request, and the output is sent back to the requester in a separate message. So, meron po tayong consideration ng big engine and little engine in the organization in the memory. So, there are issues that must be dealt with concerns to the differences on data representation on the client and server machines. So, si big engine store the most significant byte first, while the other systems known as little engine store the least significant bytes first. So neither order is better. So the choice could be dependent on the computer architecture. To resolve differences like this, RPC systems define a machine-independent representation. Siya po yung nagdi-design, and there are two approaches that are common. First, there is the binding of information that may be called on a fixed port number associated with it, and once the program is compiled, the server cannot change the port number of the requested service. Second, the binding can be dynamic. Okay, typically on operating system, it provides a matchmaker on a fixed RPC. We have the concept of pipes. A pipe is a conduit allowing two processes to communicate. They typically provide one of the simpler ways to communicate with one another, although they always have some limitations. In implementation of pipe, there are 4 issues to be considered. These are questions like, does the pipe allow bidirectional communication, or communication is unidirectional? If two-way communication is allowed, is it half duplex? Data can travel only one way at a time, or full duplex, that the data can travel in both directions at the same time? Would there be relationships such as parent and child exist between the communication that creates the processes? Or di kaya, can the pipes communicate over a network, or must the communicating process or processes reside in the same machine? On the different types of pipe. Una, we say that ordinary pipes allow two processes to communicate. The producer writes to one end. The producer writes to one end of the pipe, and the consumer reads. The consumer reads from the other end of the pipe, which is the other function. As a result, ordinary pipes are unidirectional. So, tingnan niyo po yung sequence of flow originated from this entity, like a parent process towards the child process. In the case of parent producer, so you have the producer and the consumer. Producer-consumer pala problem. So, as a result, we have the unidirectional, allowing only one-way communication. So, if two-way communication is required, two pipes must be used, with each pipe sending data in different direction. We have the named pipes. Ordinary pipes provide a simple mechanism for allowing a pair of processes to communicate. Kaya lang, si ordinary pipes exist only while the processes are communicating with one another. Named pipes provide much more powerful communication tool. The communication po kasi is bidirectional and no parent-child relationship is required. So, once a named pipe is established, then several processes can be used for communication. So, let's check on the progress sa mga pinag-usapan po natin sa buong chapter. Medyo mahaba-haba po yung chapter 3. We started with a process, which we say a process is a program in execution. As process executes, it changes its state. So, the state of a process is defined by the process current activity. Each process may be in the following state: on the diagram, new, kanina, ready, running, waiting, or terminated. Each process is represented in the operating system by its own process control block. Tapos, nung na-discuss natin si process control block, we say na a process, when it is not executing, is placed on some waiting queue. Yung job queue, ready queue, device queue. There are two major classes of queues in an operating system: the input-output request queue and the ready queue. So, the ready queue contains all the processes that are ready to execute and are waiting for the CPU. Each process is represented by a PCB. The operating system must select processes from various scheduling, either sa long-term or sa short-term. Long-term job scheduling is the selection of processes that will be allowed to contend for the CPU. Normally, long-term scheduling is heavily influenced by resource allocation consideration, especially there is memory management. Short-term CPU scheduling is the selection of the process from the ready queue. So, operating systems must provide a mechanism for parent processes to create new child processes. The parent may await for its children to terminate before proceeding. The parent and the children may execute concurrently. So, there are several reasons for allowing concurrent execution. That is for parent and children, or from parent to children. Information sharing, computation speed up, modularity, and convenience are some features. The process executing in the operating system may be independent process or cooperating process. Cooperating processes require an inter-process communication. Natagalan tayo actually dito sa inter-process communication to communicate with each other. Communication is achieved through dalawang scheme, either shared memory and message passing. The shared memory method requires communicating process to share some variables. The process are expected to change information through the use of shared variables. So, in a shared memory system, the responsibility for providing communication rests with the application programs. The operating systems needs to provide only the shared memory. So, it has to work hand in hand with the application program. The message passing method allows the processes to exchange messages. So communication in client-server systems were discussed, and that we extended the systems in client-server communications in sockets, remote procedure calls, and pipes. A socket is defined as an endpoint for communication. A connection between a pair of applications consists of a pair of sockets, one to each end of the communication channel. So RPC are another form of distributed communication. An RPC occurs when process or thread calls a procedure on a remote application. So pipes provide relatively simple ways for processes to communicate with one another. Ordinary pipes allow communication between parent and child, while named pipes permit unrelated process to communicate. Doon po natapos yung ating discussion sa pipes. So, please do prepare your questions during our synchronous meeting, and then please do expect that we have our quiz for chapter 1 and chapter 2 the next meeting. Okay, thank you everyone. I'll see you on our synchronous meeting.